Alright, 1-9 inverse functions is our section for today. And an inverse function is when we take the domain of one function and switch it with the range of another. Another way of saying this is that if you have an x and y table, some function, not sure what it is, but let's say 1 and 3 and 4 and 7 and 7 and 10. That's some points on our function. Then if we did the inverse of that function, the x's and the y's would switch. So instead of 1, 3, now we're going to have 3, 1. Instead of 4, 7, now we're going to have 7, 4. Instead of 7, 10, now we're going to have 10, 7. Alright, so and we can see right here denoted f negative 1. That's how we say the inverse of our original function. Alright, and so you can see they do say this in the longer form here. 1, 5 switches to 5, 1. 2, 6 switches to 6, 2. 3, 7 switches to 7, 3, and so on. Alright, and so when we're switching our x's and our y's, we are also saying we're switching our domain and our range, which is what they're indicating in this diagram here. And we can also find our inverse, or I'm sorry, we can check to see if two functions are inverses of each other if the end result equals x. Alright, so f of x and g of x are inverses if they undo each other. They mention it right here, and undoing each other is going to cancel each other out, and all we'll have left is x. So if we do f on g and we get x, they're probably inverses of each other, but it has to work both ways. So we also have to check to see if g of f of x is also equal to x, and if they are, then they are inverses of one another. So for our first example, we're going to find the inverse of 4x, and then we're going to verify that f negative 1 of x and f negative 1 f of x are both equal to the identity function. And just so we're clear, the identity function means x. Alright, so let's find the inverse function f of x equals 4x. What we're going to do, instead of function notation, we're just going to put a y in there for a second. And we're going to realize that for inverses, we switch the x and the y. So we just flop the places out here. So now our problem is x equals 4y, and our job is to get y by itself. To do that, we're going to divide by 4. Y is going to equal x over 4. So we're going to say that the inverse function of x is x over 4. Let's go ahead and see if that is indeed equal to the identity function. F of the inverse means that we're doing f of x over 4. And f says we're going to go 4, and then we're going to put our input in. 4 times whatever we have inside, which is x over 4. And guess what happens to the 4's? They cancel out. We're halfway home. Let's check it the other way. The inverse of f of x. The inverse of f of x is 4x. And the inverse tells us to take our input and divide by 4. 4x divided by 4. The 4's do cancel, and we do indeed get x. So 4x and x over 4 are inverses of one another. Go ahead and see if you can do this for problem 7. Problem 7 is for you. Here we go. Y equals 6x. Switch it. X equals 6. Y divided by 6. And so the inverse function of x, we're going to call it x over 6. Let's go ahead and verify this twice. F of x over 6. That's what our inverse function was, and the function says 6 times whatever we have for our input. The 6's cancel, and we have x. Let's make sure it works the other way. F of -1 of f of x is 6x. And the inverse function tells us to take whatever we have and divide by 6, and we get x.